Welcome to today's deep dive. We are really thrilled to have you with us because today we are taking a sledgehammer to a concept that mathematics has treated as an undeniable truth for, well, for centuries.
Yeah, a literal sledgehammer.
Right.
Right.
Traditionally, if you look at the landscape of math, prime numbers are treated as the universe's ultimate chaotic mystery. Like, we've always just had to accept that they're distributed essentially at random across the number line.
Which has always been the prevailing wisdom. There's supposedly no pattern, no underlying rhythm.
Just unpredictable dots,
Yeah.
scattered endlessly into infinity.
Exactly. The assumption is that you can't predict exactly where the next prime will fall without just crunching the numbers and checking.
Right. But today, our source material is this fascinating, almost rebellious collection of notes, Python scripts, and visualizations from an author known as Dado. And Dado is proposing something entirely different. So, okay, let's unpack this.
Let's do it.
What if everything we were taught about prime numbers being random, isolated points of data on a flat line, is entirely wrong? What if, instead, prime numbers are actually a beautiful, vibrating, multidimensional harmonic wave?
It sounds like sci-fi, but that is exactly the premise we're exploring today. It's a massive paradigm shift. And our mission for this deep dive is to guide you through Dado's mathematical framework.
Yeah.
We are going to look at the notes and the code provided in the sources to explore what Dado calls the hexatic log spiral. We'll look at the physics of standing waves within numerical sequences, and we're going to break down a really compelling computational concept called delta cleansing.
We're essentially looking at math through a completely new physics-based lens.
Precisely.
And before you get worried about needing an advanced math degree to follow along, I promise you, you don't. We are taking math out of those dusty textbooks and turning it into a visual, living symphony today.
We're walking through it together.
Exactly. So to start this journey, we have to talk about the first big shift in Dado's notes. It all begins with redefining the center of our numerical universe.
Right, the 0 point.
Normally, when you picture a number line, 0 is the anchor. Everything starts there. But Dado's Python scripts, specifically one titled hexed_055, do something radical. They rewrite the rules so that the number 5 is the new 0.
Which is wild.
It is. 5 becomes the center point from which the entire natural number system is built.
Which is a brilliant, if unconventional starting point.
But wait, let me push back on that for a second. If you just shift the number line to start at 5 instead of 0, aren't you just moving the goalposts? I mean, isn't that just manipulating the graph to force a pattern that isn't naturally there?
It sounds like a cheat code. I completely agree. But
Sure.
here is why it is mathematically justified in Dado's framework. In this system, space is divided into a hexatic grid.
Hexatic meaning base 6.
Exactly, just base 6. So I want you to imagine a wheel with 6 spokes radiating outward from the center. In modular arithmetic, specifically mod 6, every single number falls onto one of those 6 directional rays, which are labeled 0 through 5.
Okay, I have that image in my head. A 6-spoke wheel.
Now, when you take the traditional number line and wrap it around the 6-spoke wheel, something incredible happens. If you look at the generated hexagonal prime map from the sources, almost all prime numbers greater than 3 don't just scatter randomly around the weight.
They know.
No, they exist almost exclusively on only 2 specific rays, the ray representing 6k minus 1 and the ray representing 6k plus 1.
But let's actually test that math out loud just to make sure I'm tracking how this works.
For it, pick any multiple of 6.
Okay, let's take 18.
Right, so k is 3, making 6 times 3 equal 18. Now, what is 18 minus 1?
17, which is a prime number.
And 18 plus 1.
19, also a prime number. Okay, let's do another one. How about 24?
So 24 minus 1 is 23, prime. And 24 plus 1 is 25.
25 is not a prime. It's 5 times 5.
Exactly. And that right there, that exception on the ray, is a crucial piece of this puzzle that we're going to come back to later when we talk about delta cleansing.
Okay, I'll bookmark that.
But the larger point stands. The vast majority of your primes are going to live on these 2 specific tracks.
I have the visualization of this hexagonal prime structure right here in front of me. And it really is striking. I want you to picture this. Right in the dead center, there is a large green dot. That is the number 5, our new 0 point.
Right.
And radiating outward from that center are 2 solid, distinct lines of data points. One ray is bright blue, shooting off in one direction. Exactly opposite to it, a bright orange ray shoots off in the other direction. Those 2 rays are just packed with prime numbers.
And what about the rest of the wheel?
The other 4 directions on this 6-spoke wheel. They are completely, utterly empty of primes.
Yeah.
It is just blank space.
What's fascinating here is how instantly this visualization changes our understanding of the numerical landscape. In a single image, it clearly shows you exactly where the prime numbers live and where the massive voids of composite numbers exist.
It's like turning on a black light and suddenly seeing a pattern that was invisible under normal light.
Exactly. When you see primes lining up perfectly on opposite sides of a central pole, it completely destroys the illusion of randomness. It immediately hints at a deeper, hidden geometric structure. It justifies making 5 the center, because 5 is the fulcrum where this perfect symmetry begins.
But that geometry only gets us so far. Dado doesn't stop at just drawing straight lines. What happens when we introduce motion and scale?
This brings us to the next visualization in the notes.
Right. Dado alters the Python code. Instead of plotting the distance of a number linearly, where the radius equals the number itself, Dado changes the radius to a logarithmic scale. The equation becomes r equals log n.
The shift to a logarithmic scale is essential. As numbers get infinitely larger, the gaps between primes grow. By switching to a logarithmic radius, Dado pulls the vast, sprawling infinity of numbers into a tighter, much more observable structure.
And the visual result of that equation is stunning. Those two straight, opposite rays suddenly warp and fold into what the nodes call a hexagonal log prime flower. It literally looks like a geometric flower with 6 distinct petals.
It's beautiful.
It is. But Dado takes it even further. If you take that grid and slowly rotate the angle of the phase based on the number itself, using the formula angle equals n times pi divided by 3, you get the next visualization, called the prime sunflower.
That is where the geometry starts to look almost biological.
Absolutely. Sunflower is not an exaggeration. The image generated by this code looks exactly like the center of a sunflower, where all the seeds are packed together in those perfect swirling spirals. The numbers fill the two-dimensional plane completely evenly.
But here's the kicker.
Yeah. The primes within this sunflower pattern are not randomly scattered. They form dense, visible arcs. They cluster into density bands. You can actually see these distinct radial corridors sweeping through the image.
Traces of divisibility.
Yes. The notes explain that these bands and corridors are the visible traces of divisibility. We are literally looking at the physical footprint of multiplication and division across the number line.
Which brings us to the critical conceptual leap of this entire framework. By mapping numbers this way, Dado connects pure mathematics directly to the laws of physics. Looking at these bands and corridors, Dado posits that prime numbers are not discrete, independent dots at all.
Okay, then what are they?
They are resonant nodes in a hexatic standing wave.
Let me make sure I'm visualizing this correctly. We are talking about waves like you'd see in physics.
Exactly. Let's use a physics analogy. When you have a wave, you have a sequence of energy. In Dado's math, the sequence of numbers itself acts as the wave.
Okay.
The formula we mentioned, the n times pi over 3, provides the phase of the wave. The act of divisibility creates interference patterns, just like overlapping ripples when you throw 2 stones into a pond.
And the regular remainders left over from division.
They create nodes. Nodes are points of perfect stability within a vibrating wave. In this theory, prime numbers are those nodes.
This raises an important question, though. Why a base 6 system? Why does this only work with the hexatic phase of pi over 3?
I was wondering the exact same thing when I read the notes, but Dado actually has a very specific explanation for why the number 6 is the magic key here.
Oh, quoting the notes directly here. The number 2 kills standing waves. It's too simple. 3 turns everything into a linear flow. But 6 is the perfect compromise.
Right. 6 is the exact mathematical environment that preserves the resonance of the wave while simultaneously giving birth to these stable nodes.
It's the sweet spot.
It really is.
Mhm.
I want you to imagine the number line not as a rigid wooden ruler, but as a tightly pulled, vibrating guitar string.
Okay, a guitar string.
When you pluck a guitar string, the whole thing vibrates in a blur of motion. But if you touch it lightly at very specific harmonic intervals, certain points on the string will stay perfectly still, while the rest of the string vibrates wildly around them. In Dado's paradigm, the prime numbers are those perfectly still points. They are the harmonic nodes of stability in a vibrating numerical universe.
That guitar string analogy perfectly sets up the next section of the notes. Because if primes are acting like nodes on a string, there has to be a physical law governing that vibration.
Absolutely.
And that is exactly what Dado maps out. The code introduces something called the theorem of hexatic harmony of space, which is also referred to as the hexatic harmonic criterion of primality. This isn't just theory. It's a strict, multidimensional law generated right there in the Python output.
Let's break down the core rules of this theorem, because this is where the math gets incredibly elegant. First is the basis. The entire space of this framework is built purely on the elements 2 and 3.
Got it.
Second, we have the poles. The numbers 2 and 3 act as negative poles, while 5, our new center, acts as the neutral pole.
Okay, so 2 and 3 are the building blocks.
Right. Third are the dimensions. The theorem states that every single prime number greater than 5 possesses k dimensions. And these dimensions represent the exact number of ways you can express that prime number as a simple equation. 2a plus 3b.
Let me pause you there because I want to make sure we're not losing anyone, including myself.
Yeah.
So we are taking a prime number and we're trying to figure out how many different combinations of 2s and 3s can add up to that number.
Precisely. Let's take a prime number, say 17. You can express 17 as 2 times 1 plus 3 times 5. That's 2 plus 15, which equals 17.
Okay, I follow that. A is 1 and B is 5.
But you could also express it as 2 times 4 plus 3 times 3. That's 8 plus 9, which also equals 17.
Oh, I see. So for a given prime number, there are multiple dimensions or pathways of 2s and 3s that can construct it.
Right. And finally, we have the rule of harmony. Across all of these hidden dimensions for a given prime, the parity of those variables, meaning whether A and B are even or odd, strictly alternates. It never deviates.
Here's where it gets really interesting. When Dato's code calculates all these dimensions for a prime number, it reveals a hidden resonance. If you take the sum of the extreme dimensions for a prime, it always yields a unique harmonic constant.
Always.
Dato is making a very bold claim here, backed by this computational output. Prime numbers do not play dice. They're not random anomalies. They obey an incredibly strict, mathematically predictable, multidimensional harmonic law. They are entirely bound by the geometry of 2 and 3 interacting around that neutral pole of 5.
It's a complete reframing of how we understand numeric architecture. But, like any deep scientific theory, it has to account for the anomalies.
Right, the dead numbers.
Exactly. The system isn't perfectly clean. And that brings us to the final and perhaps most complex script provided in our source material. It's called the hexatic flow with delta cleansing.
Because as beautiful as the hexatic wave is, we already found a flaw earlier. We established that almost all primes live on the 6k minus 1 and 6k plus 1 rays. But they aren't the only things living on those rays.
Right. We did the math ourselves just a few minutes ago. If you travel down those 2 specific rays, you will hit almost every prime number. But you will also hit composite numbers, numbers that can be divided.
Like 25.
Yes. We found that 25 sits on the 6k plus 1 ray, because 24 plus 1 is 25. And if we look at 35, it sits on the 6k minus 1 ray, because 36 minus 1 is 35.
So they're on the tracks, but they aren't prime.
Right. In a perfectly resonant prime wave, these composites are essentially dead numbers. They are disrupting the flow.
And Dato refers to these specific composite numbers on the prime rays as phase tension points, right?
Yes. They are moments where the wave's harmony bends or strains, like a knot in our vibrating guitar string.
So how does the code fix a knot in a mathematical wave? The notes don't just point out the flaw, they offer a mechanical fix that I absolutely love. The code performs what it calls a delta shift.
The delta shift.
Yeah. It specifically targets these dead composite numbers that are divisible by 5. When it finds one of these phase tension points, it applies a tiny surgical shift to it, adding either exactly plus 2 or plus 4, depending on the number's position in the phase.
Let's actually test that on our tension points 25 and 35.
Okay, let's take 25. The code applies a plus 4 delta shift to it. What is 25 plus 4?
29, which is a prime number.
Now let's take 35. The code dictates a plus 2 shift for this position. What is 35 plus 2?
37, another prime number. That is wild.
It literally cleanses the dead numbers. According to the output generated by the script, this specific mathematical nudge successfully transforms 12.5% of those composite numbers back into pure primes.
The Ramanujan remainder.
Exactly. The notes call this 12.5% the Ramanujan remainder. By applying this simple arithmetic rule, the code reclaims a massive fraction of the numeric space back into the harmonic wave of primes.
If we connect this to the bigger picture, this delta cleansing script reveals something profound about the nature of this mathematical space. It shows a dynamic harmony.
Dynamic, not static.
Right. Those composite numbers living on the prime rays aren't just mistakes or random noise. They are temporary, predictable bends in the standing wave. And more importantly, they are bends that can be actively nudged back into phase resonance with an incredibly simple delta shift.
It suggests that the numeric space is fluid and correctable, rather than rigid and fundamentally broken.
Absolutely.
So what does this all mean? Let's take a breath and look at the incredible journey we've just taken through these sources. We started with prime numbers, the entities that mathematics has historically treated as chaotic, unpredictable, and frustrating.
Yeah.
But by viewing them through Dato's hexatic lens, we changed the rules. We shifted our center to the number 5. We applied the physics of standing waves. And when we did that, everything changed.
We watched straight lines fold into logarithmic flowers.
We saw random scatterings organized into beautiful swirling sunflower spirals with clear traces of divisibility. We saw how a simple delta shift can correct the bends in the wave.
And we realized that primes might just be the quiet, resonant nodes on a cosmic, vibrating string.
It is a stunning conceptual synthesis. But I want to leave you with one final mind-bending idea straight from Dato's notes. After going through all this math, all these scripts, and all these geometric proofs, Dato makes a profound philosophical leap.
This is my favorite part.
Dato claims that this beautiful harmonic structure of prime numbers might not actually belong to the numbers themselves.
Wait, what do you mean?
Dato suggests it might belong to the way we observe them. Think about that. If prime numbers are simply a projection, a visible manifestation of standing waves created entirely by our specific phase or angle of observation, then what else in our universe are we misjudging?
Oh, wow.
From the bizarre, unpredictable behavior of quantum physics to the one-way arrow of time itself, what else appears chaotic and random to us simply because we haven't found the right mathematical lens to look through?
That is exactly the kind of thought that keeps you up at night, staring at the ceiling. If the chaos of primes is just an illusion of our perspective, the universe might be a lot more harmonious than we ever dared to imagine.
Thank you so much for joining us on this deep dive into Dato's numerical universe. We hope this conversation has given you a whole new way to visualize the math that builds our world. Keep questioning the fundamental structures of reality, keep looking for those hidden patterns, and we will catch you on the next one.